Request Dr. Debasis Chakravarti of Fortis Hospital to provide his views of this mutual work, understanding and collaboration.
Good afternoon. Thank you very much, Professor Chakravarti, Professor Shah, Professor Sanjay Gupta, for giving me this great opportunity to speak to this august gathering. I am an orthopedic surgeon working at Fortis Hospital, Kolkata, and basically my remit is that I do joint replacements. And I was speaking to Professor Shah and Professor Gupta as well about the tremendous scope for mutual work between us and yourselves to improve the science that is already up and running this generation. And it was fascinating to hear Dr. Bhattacharya speak about mutual respect and understanding, and this is where I start from. Now, what I'm going to do is very briefly talk about replacement surgery. I was not aware that I would be requested to give a formal sort of presentation on this. It was just told to me that it will be just a discussion over a cup of coffee, just say whatever you want to. And I just walked in and I saw you all, and I felt weak in my knees. I sat and just prepared a few slides, so please bear with me. We perform at least around 40,000 joint replacements per year in this country. And this is growing every year. And of course, the science of replacements first started with Sir John Charnley, long time back in 1960s in the UK, and it has evolved since then. And in India, it has picked up a big way, especially in the western part of India and southern bits. Eastern parts are also growing. And the problem with this is that although it's a fantastic operation to do, but it's bound to fail. And this is the problem. Because it's a mechanical thing, we need to be aware that all mechanical things have a finite life. It has wear, and it will fail. And we need to, in a poor country like ours, need to understand the economics behind this, the human cost, the financial aspects of it. And this is where we need to evolve and be different from the Western countries, where money is not an issue. Money is an issue in our country. So we need to know that these will fail, and what happens if it fails. And that is, you can see hip replacement done very beautifully, and you can see the osteolysis that happens near the screws, where bone is eaten away, and ultimately the cup will work itself loose and it will fail. And we need to revise this. And the average cost for revising this knee, revising as in changing it to another new one, will be approximately 4 to 5 lakhs. And how many of us can afford that in our country? So the cost is a big issue over here, and we need to be aware that although we have the expertise and the skills to perform these, cost is an issue. And this is where we can come together. Our collaboration is very important. Where can we evolve? We can take your brains and put our minds together and see whether we can design things which has less failure, or the failure mechanisms are taken care of, so that the longevity of the implant is more. And how can we do that? We can look into the biomaterials bit, and you have a huge section. I was speaking to one of our colleagues over here to look into the biomaterials, the tribology, the failure mechanisms, and see how, because the wear particles are the main cause for failure, where the body mechanisms react to the wear particles and cause failure, cause osteolysis, or bone being eaten away by osteoclasts, one of the cells in our body. So we need to look at the tribology, look at the wear properties, and see whether it can improve the wear properties, which will help in longevity. We also need to look at the bearing surfaces, how we can see if the bearing surfaces could be improved, the surface properties can be improved, whereby there will be less wear particles. And the bioengineers have a huge role to play Fixation-wise, the commonest mechanism that we do, the commonest thing that we do to fix an implant is cement. And what we have today is cement disease, whereby cement particles become loose and they go into the system and they cause all sorts of funny problems. So nowadays, prostheses have evolved to have fixation without cement, so cementless fixations. Now, when we talk about cementless fixations, again, the cost is just vastly different. And I will give you an idea. A cemented hip replacement will cost around 1.5 lakhs in our setting, whereas the uncemented ones will cost anywhere between 2.5 to 3.25 lakhs. So it's just almost double. So we need to see if we can improve on the material cost factor as well, so that we can reduce these costs to make it more affordable for our patients. So the aim is to reduce the failure mechanisms and thereby increase the longevity of the prosthesis. And I'm very, very keen to set up a sort of a bioengineering research team, putting all our minds together to see where we can help. And ideally, they should consist of biomechanical engineers, biomaterial scientists, biologists, and of course us putting in the last bit of the jigsaw puzzle in place so that we can all come up with a solution. And ideally, they should have the following capabilities. These are my personal thoughts, so please feel free to correct me if you wouldn't mind. First of all, we need to look at the biomechanics. The uni and multi-axial testing facilities are there in your labs. I've gone to IIT Kharagpur. I've seen that you have fantastic facilities over there whereby we can work on these. Also, the material property characterization is important, and we can see whereby we can create more less costly biomaterials which have less wear rates. Can we do that? I'm sure we can. We have come a long way over the last 50 years. I'm sure, there's a lot of material that goes into making cheaper but more resistant, wear-resistant biomaterials. We need to have failure analysis capabilities which will improve our understanding to the nature of the failures, the failure mechanisms. If we understand why it's failing, then we can take steps to prevent its early failure. And one of the causes of early failure is, of course, bad surgery. And that is a completely different set of arguments. You need to improve your surgical skills. You need to be well trained to put in a hip or a knee absolutely correct, so that the biomechanical stresses are almost simulated as normal. So that is a part of the training for the surgeon. That you can't help. But what you can help is to improve the materials and the fixation. And also, it's important to have the facilities for internal stress analysis, three-dimensional motion tracking. I've seen simulators in your lab whereby you load and stress a biomaterial, and see the amount of wear that is generated. It is there in your lab, and we can work on that. Tissue permeability and in situ mechanical testing. Of course, in one of the morning lectures, I think Professor Chakravarti's lecture, I saw a bit on medical imaging, and we can, of course, use these before, during, and after surgery to see where we are going wrong. What should we do to improve our placing of the prosthesis, and also, while doing surgery, if we can have something which will tell us, that yes, this is the correct way, then it will help. What we have now is computer help from the scanning. Now that is a very cumbersome procedure. If we can improve on that, something like as simple as an X-ray or a fluoroscopy, then it will help, because the computer navigation process that we have costs 40 lakhs or something, an absurd amount of money, and most of the common hospitals will not be able to get it. Also, it requires a lot of training. So if we can have something as simple as fluoroscopy or X-rays, which gives us an idea about device control, and these x-rays are not ordinary x-rays. I'm not talking about ordinary x-rays because it doesn't make any sense to take x-rays and take it to the lab, digitalize it, come back. You don't have the time. So if we can look into this, then it will help. And also, obviously, the computer tomography and MRI will also help. And during my recent visit to IIT, I had the great opportunity to meet Professor Chakravarti, and we were speaking about trying and arrange a short-term course on biomechanical implants and biomaterials, etc. And I have put in a bit of effort with Professor Gupta and Professor Shah to see if we can do it. Please have a look through if you do have a leaflet in your bag. And please, I would be quite grateful if you could kindly put in some input to see if we can improve this course somehow. With these few words, let me thank you once again for giving me the opportunity to present my small thoughts on how to improve continually evolving science. Thank you very much.
Thank you, Dr. Chakravarti. Thank you, Dr. Chakravarti, for an excellent talk and another example of what IIT and the doctors can do together.